Hey guys, I thought I'd pop on with something else here. Okay, I got them pulled up, the Magnetopause Z-Cut, which is looking, if you were like seated above the North Pole, you'd be looking down on the Earth. That's the Z-Cut. This shows the solar wind coming from the direction of the sun. This is the Earth, the lighted part facing the sun, the dark part facing away. These arrows should always be heading from right to left because there's only supposed to be one solar wind pressure in our solar system. But of course, it's quite evident now that we have a binary twin sun called Nemesis, and it's in the neighborhood. Here's the magnetopause. This should be around 10 Earth radii from the Earth. This is our basically a representation of our magnetosphere, which is protecting our planet from the sun's solar wind and radiation. It's hanging out there around 10 for the most part here in this representation. But as you can see, it's getting crumpled around. This is due to the pressure coming from, as you can see, these arrows from the back side. So this should always be like a nice smooth straight line. This is the bow shock. Picture this as being a boat, the magnetosphere, and as the solar wind hits it, it piles up just like waves would in front of a boat, and that's what you have seen represented here, all this solar wind energy. Now that's what I wanted to show you. You can see this magnetopause keeps fluctuating up and down, which would indicate there should be some solar wind pressure that's doing it. But if you pull up the last 24 hours on the ACE satellite, here's the solar wind speed listed here. It's really rather light, below 500, and you can see it's fairly constant. So there's no reason why that magnetopause should be rocking and rolling like it is. And then thought I'd do some little more research. And believe it or not, I do research as best I can this stuff so that I can understand it. So I went to this here, which is really quite handy. I'll put the link below the video. This kind of pretty much explains where the ACE satellite's located, and it's at the Lagrange point L1. So here's Earth. This is like Lagrange points are points where a satellite can orbit and stay in the same position all the time relative to the Earth and the Sun with really out any trouble. It's just like kind of stuck there based upon physics, electromagnetics, gravity to a much lesser extent, of course. But at any rate, that's L1. So the ACE satellite sits out here at L1, so it's between the Earth and the Sun, which and it's at about 1.5 million kilometers away. Pretty sure a kilometer is about 0.62 of a mile. Yeah. So I did the math. It's about 930,000. Say satellite sitting about 930,000 miles away from the Earth, between the Earth and the Sun. So that being said, now if you've been watching my videos at all since my channel came back online in the middle of January this year, I started noting on the ACE 7-day graph, which it doesn't seem to show up as much there anymore. So they might be obfuscating that a little bit to hide this. But look here, you can see right around the 2300 hour up to maybe hour 02, you have this big gap. And that's been going on for several months now. Gap in the ACE data. So, my theory is something's out here, and it's got to be pretty big, fairly close to this ACE satellite, blocking this data, because it happens every day around the same time. Unless they have it calibrated to do so, but I don't think so. So anyway, there you have it. These are other Lagrange points, like where some other satellites might be. For instance, this is where stereo A and stereo B are located along these Lagrange points. So, I thought that was pretty interesting. Then we come down here. This explains all about the solar wind and this graph you're seeing up top here. Speed, density, temperature, and these are the angles, BZ and the phi angle. What I was wanting to look at was this phi angle. The phi, that's the interplanetary magnetic field between the sun and the earth. Now, it explains that this system, you can read it for yourself, but what kind of threw me off here was look at this phi angle. It's way up around 360. According to that article or that little description, if it's facing the sun to the earth, exactly it would be 180. See? This means that a phi would be 0 if it were pointing at the sun, and 180 degrees if it were pointing from the sun to the earth. So, if it's 180 degrees pointing from the sun to the earth, and it's 0 degrees if it were pointing from the earth to the sun, then what the heck would it be if it was 360 degrees? That, to me, from the description here, would tell me it's pointing from the earth. Okay, let's look at this Lagrange point again. So, if it's 0 degrees, if it's pointing from the earth to the sun, it's 180 degrees if it's pointing from the sun to the earth, then what would it be if it was 360 degrees? Well, I would submit, and I'm not, of course, not 100% sure about this, but it would stand in my form of reasoning that 360 degree phi angle would be from the earth out here to another solar body. You see what I'm saying? This is crazy stuff, guys. So anyway, I'll leave that link for you. You can do your own research. Here we got the pockmarked Earth still showing up. Got the clouds in the magnetic grid resonance pattern, which now you really have to click full screen to see this helio viewer that I'm showing you. Here's the magnetic resonant grid pattern around the sun too on the SDO at the 335 angstrom, and also it shows up pretty well at the 94 angstroms. Then we go to, I've showed you this before, SOHO at the 195. There it is. There's a grid pattern, magnetic resonant grid pattern. There's a square up here, and that's what they're blocking off there, huh? And then at 304, it's also doing it. These, I watch these movies. These are, I've seen people put up videos to try to suggest that these were UFOs or something like that. But really what they are is some kind of a magnetic bubble that forms, and then it eventually it breaks away and just goes. You can watch if you pull. I'll put the link down for this Helio viewer, and you can watch these if you want. You'll see what I'm talking about. So there we go, back to the clouds. We got the same grid pattern, I would submit. So that tells me that there's some kind of a serious electromagnetic influence going on between the Earth and the Sun and Nemesis. It even shows up in precipitation patterns. See what I'm saying? Then if you shift it to clouds again and we zoom in a little bit, we'll zoom in on North America since that's where we're at. And I'm seeing all these little gradients around here. Now, if you're not on full screen, you're probably not seeing this, but I don't recall seeing anything like that before. That's showing, to me, the clouds are being affected by some kind of electromagnetic connection between the Earth and the Sun, Earth and Nemesis. And it's showing up. See how it's like stacked? It's like sort of a pattern in and of itself. And I never saw that before. I started noticing these grid patterns, so could have been there, but I never noticed it. So there's that. There's Earthquake 3D, the one I have. It's an extra $20. You get it where it shows the depth of the earthquake. So the higher the circles raised above the globe, that shows you how high the earthquake is. You click on kilometers, that shows you the depth of the earthquake. 226, that's getting pretty deep. But when you get down into this 583, 523 range, that's crazy deep. So, because the asthenosphere, which is down that around 450 kilometers and below, or 400 kilometers and below, somewhere in that range. You know, how do they know for sure? But I've seen different reports. That's either more plastic, so it's not prone to much earthquakes, and that would seem to stand to reason since there's got to be more heat down there, and or it's much harder, which also might stand to reason since there's more pressure down there. But nonetheless, earthquakes down that low are quite rare, but they have becoming quite common ever since this Nemesis binary twin solar system entered the picture a few years back. Now we're seeing them quite frequently, and usually they portend shallower, stronger earthquakes nearby. So we'll get off that. We had a 6.0 hit up in the Philippines. For some reason, it's wanting to hide it. I mean Mexico, I'm sorry. Here we go. 6.0 right off the coast of Mexico, and it was at a 24-kilometer depth, so shouldn't have been any tsunami or anything going on. That's the first 6.0 we've had. This USGS has actually reported as a 6.0 in quite some time. Seen some that were just below 6, but that could have been downgrades on their part. So anyway, I'll let this play through. Only got 30 seconds left. So you see what I'm talking about with that ACE data, solar wind. This shouldn't be fluctuating that much because the solar wind's pretty much been constant the last 24 hours. These here are the, of course, the electron counts belts. This is the lowest energy, and this is at the high energy. And you can see this is like backside. You can see the backside of the magnetopause here.